Hi everyone, this is Nicole with Titans of CNC Academy, and in this video I'm going to show you how to program the TITAN-1M from the Building Blocks series using Mastercam. So before we begin, you want to make sure that you download the TITAN-1M print if you haven't already. This is the same print that we used to design the TITAN-1M. You'll also need to download the setup sheet, which contains the tool list and setup instructions, as well as the Mastercam Building Blocks tool library. All of this can be found in the related files section of this video. So the first thing we want to do is import our file. So I'm going to come up to File, I'm going to drop down to Open, over to Computer, and Browse. Next I want to navigate to the folder where my part is located. Mine happens to be located in this folder here, but as you can see, nothing's showing up, and that is because we have our file type set to Mastercam files. So I'm going to go ahead and choose this drop down to change it to my file type, which happens to be a step file. Now I can see my part, so I'll go ahead and select it and choose Open. So now it's loaded my part. So let's go ahead and start setting up some things. So I'm going to start by coming over to the Machine tab, and I'm going to set up our machine. So I'm going to come over to the Mill drop down, and I'm going to choose Default for this tutorial. This is where you would choose your machine's post file. And now you can see it's created Machine Group 1. So this is where all of our tool paths and stock and everything for this program is going to be located. The next thing I want to do is set up any geometry that I'm going to need for my toolpaths. So I know that the majority of the toolpaths on this part are going to be two-dimensional toolpaths. 2D toolpaths only care about the geometry you select and the parameters that you set. It's not reading any other geometry. It's not reading any solid models. It's going based off of 2D geometry. And 3D toolpaths can use what is called rest machining, which allows the toolpath to take into account what previous toolpaths have already machined, as well as stock material. And I know that one of our toolpaths is going to be a 3D OptiRough. This toolpath is going to be roughing out the majority of the material around the part, and so it needs to have a good idea of what material needs to be removed and where all the geometry is. So for that toolpath, we're going to create a stock model so that we can reference the stock model in that toolpath so it knows exactly what material needs to be removed. So that's something to keep in mind when you're dealing with 2D or 3D toolpaths. 3D is going to be reading a lot more of the solid geometry, whereas 2D is going to be really just reading that 2D wireframe geometry that you selected. So since I know I'm going to be using the 3D OptiRough toolpath, I'm going to go ahead and set up my stock model now during our setup process. So to do that, we need to create a solid model around this part that represents our stock. So anytime we're creating any new wireframe or solid geometry, it's best to put it on its own level so that it can be toggled on and off independent of the model. So I want to come over to our Levels tab here, and you can see our current level, Body 1. This is what our model is on. I want to create an additional level to put our new geometry on. So I'm going to give it a new number. I'm going to do number 2, and I'm going to give it a name. I'm just going to call it Stock. Now you can see the new level here. It currently doesn't have anything on it, but it is active. This check mark means that we are currently active on this level. So anything that's created at this point forward is going to be on this level until we activate a different level. So now that I've created a new level, I'm going to come up to my wireframe tab, and basically I just want to create a box around this part. So the quickest way to do that is to come up to the Shapes tab and choose Bounding Box. Now it's asking us to select one or more entities, and since I want the bounding box to be around our model, I'm going to choose our model and click End Selection. Now you can see it's previewing a bounding box here. Now, since this bounding box is going to represent our stock, I want to make our sizes match the stock size on our setup sheet. But I can see, looking at the sizes, that we're not in the correct orientation, since Y should be 1.9 and Z should be 0.75. So the quick way to change our orientation here is just to click this guy. Now, I'm just changing orientation. I'm not concerned about the location of this, so I'm just going to snap it to one of our holes. And now that it's snapped to one of our holes, I'm going to go ahead and change the orientation. Now I know that I want Z pointing up, X pointing down the length of the part, and Y pointing the width of the part. So I'm just going to click this grab handle here, and I'll move my mouse up, and you can see it's giving me an angle. And I can go ahead and just type -90 so that it'll be pointing perfectly straight up. And I'll hit enter and enter again on my keyboard. So now Z is pointing up, X is pointing down the length, and Y the width. You may have to rotate this on yours several more times to get to this orientation, but this is what you want. Z pointing up, X the length, Y the width. So that looks good, so I'll hit enter again. And now you can see our sizes are now in the correct orientation. So one thing I want to mention is our origin. I'm setting to the center. This way, any size I add on here, it'll be evenly split between both sides of the part. I also have my origin set to the top of the part. I know that our stock that we're creating here is just going to be used for our roughing toolpath. And typically on most parts, I'm going to be doing a facing operation before we get to the roughing operation. And you'll see the process is going to be the exact same on the majority of the parts as we go through this series. We're always going to be starting with that facing operation, and then we're going to go on to roughing out the outer profile and the pockets, and then finally adding all the small details and features like holes and threads and chamfers. When we get to our 3D OptiRough toolpath, we're already going to have cut the top face of the part. And since I know that my 3D OptiRough toolpath is going to read all of the stock geometry and cut any material that it sees around this part, I want to make sure that I'm not including that 20 thou on the top surface for this stock model. That way it's not sitting up here cutting the top face that's already been cut. So I'm setting my origin to the top so that we only add stock material to the bottom. So now that we've got our origin set to the top center, looking at our setup sheet, I can see that our X, or the length of our stock, is 4.1. So I'll go ahead and type 4.1. And since our origin is set to the center, it evenly adds material on both sides of our part. So you can see. And we'll do the same thing for Y. We can see, looking at our setup sheet, that our width of our stock is 2 inches. So I'll type that, and it added that material. And now for our Z, we know that this is 1 inch material, and we will have already faced off 0.02 on the top of our part when we get to our OptiRough toolpath. So 1 inch minus 0.02 is 0.98. So I'll go ahead and type that in. And you can see it added all of that material on the bottom. All right, perfect. So the only other thing I want to make sure is for our create geometry, we have lines and arcs and also solids. So now that I've done all that, I'm going to go ahead and click OK. And now you can see it's put 13 entities under our stock level, and it's showing our model that represents our stock here. And if we wanted to go ahead and toggle the stock on and off, I would just make our body level the active level just by clicking there. And then I can choose this X, and then I'll turn it off. But for now, I'm going to leave it on because we need it for a few more steps. So right now, this model we just created is just a model. It's just a rectangular solid body. Mastercam doesn't quite yet know that this is our stock. So we need to tell Mastercam that this is a stock model so that we can use it in our OptiRough toolpath to reference to. So I'm going to come up to our Toolpaths tab, and I'm going to choose Stock Model. We'll go ahead and just name it Stock. I'm going to uncheck Stock Plane, and I'm going to choose for our initial stock shape model. And I'm going to hit the selection arrow, and now we're going to select that model we created, and then we'll hit end selection. So this will take that model we created and turn it into stock that we can reference to in 3D toolpaths. So now I'll click OK. And if we come over to our toolpaths tab, you can see it's created that stock model and it's put it in our machine group here. So now we can reference to it. So the next step we want to do is set up our workpiece origin. So just like in the machine where we set our X and Y and Z origin, we also want to do that here in Mastercam so that they match. So in order to change our origin, we're actually going to be creating a new plane. So you could come to this tab here and create one there. A quick, easy way to create a new plane is just to click this guy here. And now we're creating a new plane. And I'm just going to snap it to the corner of our stock model that we created. You might be asking, why did we do the back left edge? The back edge of your vise is usually going to be a fixed point. It doesn't move, and so any features that are machined based off of that back edge are going to be a lot more consistent, and it'll be easier to adjust your offsets, to get things into tolerance if you're basing it off of a fixed point like the back jaw. You could do the back right edge, you could do the center. What really matters is consistency. We always shoot for back left edge. Now the reason for this is because this reduces your chance for error. If one day I set it as back left edge and the next day I set another part as back right edge, it can get really confusing really fast. So the key here is however you do it, always do it the same way. And we're consistent in the way we program, consistent in the way we set up, consistent in the way we operate. That consistency will not only reduce the chance of error, but also it increases efficiency, which is very important. So we want to, once again, make sure that Z is pointing up, X is pointing down the length, and Y is pointing to the back. So I'm just going to click this grab handle here. I'm going to move my mouse up. I'm going to type -90, hit enter, and enter again. And now we got X pointing down the length, Y pointing to the back, and Z pointing up. So that's exactly what we want. So just like when we're setting this up in the machine, we want to refer to our setup sheet and see that once we've established the edges of our stock, we want to move in, meaning toward the center of the part, on X and Y, so that our part is centered within the stock. So since we've created this stock model to represent the actual size of our stock, we'll go ahead and just use the same offsets in our setup sheet. So looking at our setup sheet, I see that we need to move in on X 0.05. So I'm just going to click this long handle here and I'll move my mouse in. Now notice we're moving in a positive direction, and that is because we're moving in the direction that the arrow is pointing. So anything that's traveling in the direction the arrow is pointing is a positive number, and anything that's traveling in the opposite direction the arrow is pointing is a negative number. So in this case, we're going to do 0.05 and hit enter and enter again. And now you can see it's moved our origin in 0.05. Now we're going to do the same thing with Y. So I'm going to click this grab handle here, and our setup sheet says that that is also 0.05. So this time it's going to be a negative number since we're moving in the opposite direction the arrow is pointing. So I'm going to do negative 0.05 and then I'll hit enter and enter again. Now we've got our origin perfectly aligned to our part. So that looks great. Now for our Z, when we're setting up our origin on the machine, we're going to be setting our Z right on top of the stock, and then we're going to tell it that the part is 0.02 below that because we're going to be facing that top 20 thou. But our Z origin is at the top surface of our part. So I'm just going to leave our Z where it's at because it's already aligned with the top surface of our part. So that's exactly where we want it. So now that we've got it in the correct orientation and the correct location, I want to go ahead and give it a name. So we're going to name our new plane after the work offset that we're going to be using on the machine. So I'm going to go ahead and just name it G54. Then I'll click OK. Alright, so the last thing we need to do before we can start programming our toolpaths is to set up our tool list. So I'm going to come up to our tool manager under the toolpaths tab. And you can see Mastercam has the default tools here, but we want to import our building blocks tool library that we downloaded earlier. So I'm going to come to this folder here, and I'm going to navigate to where I have my Mastercam building blocks tool library. I'll go ahead and choose the tool library and select open. Now you can see it's showing our entire tool library here, but I'm going to go ahead and add the tools we're going to be using to our machine group. So looking at our setup sheet, I can see that tool 1 is a 3-inch face mill, so I'll choose the 3-inch face mill, and I'm going to hit this up arrow here. That's going to put it in our machine group 1. Tool 2 is a 3/8 end mill, so I'm going to find our 3/8 end mill, and I'll hit the up arrow. Tool 3 is a 1/4-inch chamfer, so I'm going to locate the 1/4-inch chamfer and pop that up there. Tool 4 is a .1772 drill, and I'll find that guy, pop it up. And tool 5 is a 1032 tap. So we can see our taps here. So we've got 1/4-20 and 1032. So I'll select the 1032. And now you can see all of our tools are up here, but they aren't numbered correctly. So let's go ahead and get them numbered correctly so that there's no question later. So we know tool 2 is the 3/8 end mill. So I'm going to select the 3/8 end mill, right click and click edit tool. And I'm going to hit next. And you can see it's showing our tool number here. I'm just going to change that to number 2. And I'm going to click in any of these fields here, and you can see it automatically changes the length and diameter offset to tool 2 as well. It's very important that those numbers match the tool number. Then I'll click finish. And we know that tool 3 is the 1/4-inch chamfer. So I'll right click the 1/4-inch chamfer, hit edit tool. Next, I'm going to type 3, and then I'll click and hit finish. Tool 4 is our drill, so I'll right click, edit, next, type 4, finish. And then the last tool, tool 5, is our tap. So I'll right click, edit, next, and that is tool 5. And then finish. Okay, so now all of our tools are numbered correctly and loaded and ready to go. So I'll go ahead and click OK. And now we're ready to begin programming our first toolpath. Alright, so the first toolpath we're going to be using is a facing toolpath. This is important to establish that top face before we start all of our other toolpaths. This way, as we're finishing pockets or holes or threads, we can measure the depth based off of that top surface right on the machine and make corrections as needed, and we know it's accurate because we've already created that top plane, that top surface. So I'm going to come up to the 2D menu and choose face. Now it's asking us what we would like to machine. So I have my mode set to solids 3D, and I'm going to set my selection method to face. This way I can choose the top face of our stock model that we created. So it'll select the entire rectangular boundary of our stock model. So now you can see it's selected that entire perimeter, and now I'll click OK. And you can see it's showing our geometry here. In our tool tab, we're going to be choosing that 3-inch face mill. We're going to be running this at a feed rate of 25 inches per minute. For our plunge rate, since we're going to be plunging outside of the material, I'm going to go ahead and set that to 100 inches per minute. Now the reason for this is anytime we're not engaged in material, I want to make sure that the machine is moving as fast as possible to be as efficient as possible. So I'll leave our plunge rate a little higher. 100 is fine for this tutorial, but to give you an idea of kind of the thought process behind the way we program is that anytime the machine is not engaged in material, you want to be able to move as quickly as possible to be as efficient as possible. For our spindle speed, I'm going to set that to 4,000 RPM. And I do want to make sure that rapid retract is checked. For the same reason, when it's not in the cut and it's retracting, it's going to retract at full speed. In our holders tab, I don't need to mess with anything in here. If this was on a 5th axis machine, or we had some fixtures and clearances that we needed to check our tool holder against, this is where we would create that tool holder. But in this case, we don't need it. In our cut parameters, for our style, I'm going to set that to 1 pass. Now, this is a 3-inch face mill, and this is 2-inch wide stock, so it should be able to do it in a single pass across the part. For our long overlap, 110% means that it's going to come all the way off, plus a little bit, to give us a little bit of wiggle room to make sure that the shell mill is completely off the part before it lifts or drops down into the cut. So I'll go ahead and leave that at 110%. Since we're only doing this in 1 pass and we have our long overlap already set so high, I'm going to go ahead and set our approach and exit distance to 0, since we've already got enough distance with our long overlap here. We'll go ahead and leave our tip comp to tip. Corners doesn't matter because we're just going 1 pass straight across. Stock to leave, I want to make sure that we set that to 0. This is a finishing toolpath, so we're only going to be taking 20 thou of material, but it's 1 pass finishing that entire top surface. For depth cuts, again, we're just dropping down and taking 1 cut across the part. We don't need depth cuts. If we were taking a lot more material off, then we could do it in multiple steps, but in this case, 20 thou should be perfectly fine to take in 1 pass. In our linking parameters, so again, like earlier, we were talking about consistency. We like to run everything from absolute, so I'm going to make sure everything is set to absolute. Now, the reason for this is because absolute is going to be based off of our work origin. So wherever our Z work offset is, which happens to be the top surface of our part, all of these numbers are going to be based off of that. So when we're programming, if it's a positive number, we're up in space in a safe plane above the part. If it's a negative number, we're below the top surface of the part, probably engaged in material, and there's also a potential that it's crashing. So we know that negative numbers are below the top surface of our part. Positive is above. So if we have it set to absolute, it'll always be that way. And if we always set it to absolute, it'll reduce that chance for error because of consistency and clarity, knowing that anything negative is engaged, anything positive is in space and safe. So I'm going to set our retract to 0.2. Anytime it retracts out of the cut, it's going to retract to 0.2 inches above the top surface of our part. For our feed plane, I'm going to set that to 0.1. So at 0.1 above the part, it's going to start that 25 inches per minute feed rate as it's dropping down before it takes the cut. For our top of stock, we're going to leave that at 0 since it's just taking 1 pass across the top of the part. If we were doing multiple depth cuts, then we would add a number here, whatever the difference is. But since we're just doing this on 1 pass, we can go ahead and leave that at 0. For our depth, we're also going to leave that to 0 since this is an absolute number and it's based off of the top surface of our part. 0 is the top surface of our part, and that's where we want the face mill to go. So everything looks good. I don't need to mess with this tab. We'll go ahead and just leave everything in here alone. Same with our tolerance tab. I don't need to mess with any of that. In our planes tab, I want to double check that all of our planes are set to that G54 work offset we created. If they're not set to the plane you created, we'll go ahead and just open this guy here on each one, and it'll allow you to select that plane you created. In our coolant tab, I want to make sure that flood is set to on. And then anything past the coolant tab, we don't need to mess with. That's all for much more advanced controls. So now I'll go ahead and click OK. And I'll zoom out so you can see this is showing a preview of the toolpath. So the top of this yellow line here represents our retract plane that we set. So this is 0.2 above the part. So anything above this, it's rapiding down to, it's going at full speed down to that. Then it's going to use that 100 inches per minute plunge rate that we set till it gets to the top of this green line. So the top of the green line here is our feed plane. So now we're running at 25 inches per minute, and then it's going to come down and it's going to come straight across the part at that 25 inches per minute, and then retracts at full speed away from the part. So let's go ahead and preview this. If I have my toolpath selected, I can choose backplot selected operations. And now that's going to show a preview of our tool here. And if I hit play, it's just going to show you exactly what the tool is going to do. It's going to go right across the top face of our part. And you can see it's going to come all the way off of the material before it lifts. Perfect. Great, so now we have the top face of our part finished. And now the next step is going to be to rough out the majority of the material. So I'm going to click OK. And now I'm going to come up to our 3D toolpath tab here, and I'm going to choose OptiRough. Now you can see our columns here for machining geometry. Right now it has nothing selected. So this is where we tell Mastercam what geometry we would like it to machine out. So I'm going to choose the selection arrow here. And to make it easier to select, I'm actually going to come to our levels tab over here, and I'm just going to toggle off our stock level that we created. We no longer need it at this point. And then I'll come back to our toolpaths tab. So now it's asking us what features we would like it to machine. And since we want it to machine anything it can reach, I want to select the entire model. That way it can read every surface and determine what the best course of action is. So to select the entire model, you can see here it says triple click to select the solid body. So I'm going to triple click, so click 3 times, just like that, and then choose End Selection. Now that it's got our entire model selected, I do want to change our wall stock and our floor stock. So what this is basically how much material it's going to leave behind after it's done machining with this toolpath. So the reason we're leaving material behind is because typically when you're making parts, you always want to rough out the bulk of the material. And when we say rough out, we literally mean that. I mean, we want to rough cut it. We want to get it cut as quickly as possible, just remove all that material and not really care how close it is to the final tolerance. So the reason we leave a little bit of excess material around every surface is so that we can come back with a more accurate toolpath to clean up that last little bit of material and just dial it in to perfection. So the amount of wall stock and floor stock, it varies from part to part and depending on what type of toolpath and material and tool you're using. But for this tutorial, we're going to set wall stock and our floor stock to 5 thou. That's a good number to start with. And you could play around with stock to leave a little bit once you get to more advanced stuff. So I'm going to do 0.005 on both wall and floor. So at the bottom of the pocket, it's going to leave 5 thou of material, and on all of the walls of the part, it's going to leave 5 thou of material. So next in our toolpath control tab, we want to set a containment boundary. So we're basically telling Mastercam where the tool is allowed to travel outside of the part. So I'm going to come up to our boundary chains and choose the selection arrow. Now I want to choose the very outer profile of our part. So I'm going to turn off our face filter, and I just want it set to edges. I want to mouse over the very outer profile edge of our part. So that would be this line here. I'm going to hold Shift on my keyboard and I'll select. So that automatically chooses that entire chain around the outer profile of our part. And then I'll go ahead and click OK. Now I don't need to mess with our strategy. When we go ahead and select our stock model that we created, it chooses our strategy for us. But in our compensate to, I want to set that to outside. We're telling the tool it's allowed to travel outside of that boundary chain we selected. But now we need to tell it how much it's allowed to travel outside of that chain. So we want to make sure that include tool radius is checked, and we're going to set our offset distance. Now, when deciding what to set your offset distance to, typically we want to make sure that the offset distance is greater than the distance from the edge of our part to any point on the edge of our stock. So whatever the greatest distance is between those, I know in this case that it's not very much, but I'll go ahead and add an offset distance of 1 inch. This way it's basically allowed to travel as far outside of that boundary chain we created in order to clean up any stock material that it needs to. So I don't need to mess with anything else in here. In our tool tab, we're going to be choosing that 3/8 end mill. Now, when programming a part like this, when we're selecting what end mill to use to finish it or rough it out, typically when you're roughing, you're going to be using a different end mill, whatever the biggest end mill you could fit around this part for roughing, and then you would come back and dial it in, possibly with a smaller end mill, depending on the part features. But in this case, we're using 1 end mill to do both, since this is for learning. That way we don't have to mess with a whole bunch of different finishing versus roughing tools, but just so that you know, typically when you're running production parts, you're going to have a roughing end mill and a finishing end mill, and the roughing end mill is going to be pushed a lot harder and faster, whereas the finishing end mill is going to be more for the delicate finishing and slower speeds and just dialing in the features of the part. But one of the ways we select what size end mill to use is by looking at the part geometry. So we know that looking at our print, that the internal radiuses in our pockets is 0.195. So we know that we need an end mill with a smaller radius in order to clean up that 0.195 radius. So you always want to make sure that your end mill's radius is slightly smaller than the smallest internal radius in order to clean it up all the way. And we know that our 3/8 end mill has a radius of 0.1875, so we know that that is definitely smaller than the internal radiuses on this part. So that's something to keep in mind when you're programming future parts, is to look at the geometry and kind of let it tell you what size tools you can use. So we're going to be running this with a feed rate of 25 inches per minute as well. And again, since we're going to be plunging outside of the material, let's go ahead and set our plunge rate to 100 inches per minute. For our spindle speed, I'm going to set that to 4,000 RPM. And our retract, we could set that to 50 or 100, but we can also check rapid retract, which will allow it to retract at full speed when it's not in the cut. So again, for this, we don't need to mess with the holder tab. In the stock tab, we do want to check rest material. So this is where it's going to tell Mastercam to use that stock model we created in order to calculate what needs to be removed for this toolpath. So I'm going to choose one other operation, and it's going to automatically select that stock model we created. I don't need to mess with anything else in here. In our cut parameters, I do want our cut method set to climb. We want to climb cut around all of the surfaces. Climb cutting is a lot easier on the machine and the tooling. And for all of our tool paths on these tutorials, we're going to be using climb as our cutting method. Climb cutting is where the teeth of the tool are climbing up the wall of the part. Whereas conventional cutting, you're essentially going against the grain of the teeth as you're cutting. So if the tool is spinning in a clockwise direction and you're moving against that direction, counterclockwise, on an external surface, you're going to be conventional cutting, and that's a lot harder for the machine to push that tool through a conventional cut than it is to climb against the wall of the part. Tip compensation, I'll go ahead and leave that to default. Our optimized step up and step down, I'll go ahead and leave those to default. This is something that you could play around with if you wanted to change the order that it machines, like if it starts with the pocket first or the outer profile first. You can mess with those here, but I'll go ahead and leave them to default for this tutorial. For our step over, I want to set that to 10% of tool diameter. So it's going to be at 0.0375. So that's how far it's going to step over each pass through the material. For our step down, I just want it to go all the way down to the bottom and make a cut. I'm not going to do multiple steps down the part. So since we know that the part is 0.75 thick, I want to actually go a little bit past that. So I'm going to put it at 0.76. This way it cleans up all the way around below the bottom surface of our part. That way when we flip the part over and machine the second side, we have a little bit of clearance between the hat left over on our stock and the finished walls of our part. I also want to check step up. This will allow the tool to step up onto this step and into this pocket. The number doesn't matter too much as long as it's smaller than the distance between the bottom of our part and the smallest step. So I'm just going to set that at 0.05. The minimum toolpath radius is how tight of a radius the toolpath will make into corners. So I'll go ahead and just leave that at default, which is 20% of tool. Micro lift distance, that's how much it's going to lift when it needs to loop back around in order to climb mill the next pass. So 0.01 10 thou, that should be fine. I'll leave that to default. And back feed rate is when it's lifted that 10 thou, how fast it's going to move to the next cut. So 100 inches per minute should be fine. For our gap size retract, I want the tool to stay down in the cut. I don't want it doing a bunch of lifting. So I'm going to leave that to never. And we'll leave it to a default of 500% of tool diameter. That looks great. In our transitions tab, I do want our entry method set to helix only. This way it'll spiral down into the cut, taking a small amount until it gets to the bottom of the pocket. I'm going to set our helix radius to 0.15. Always want to make sure that our helix radius is slightly smaller than the radius of the tool, so 0.15 should be fine. Our Z clearance, I'm going to set that at 0.1. So this is how far above the top of the part it's going to start that helix down. This just gives us a little bit of clearance so that it's not plunging down into material at all. For our plunge angle, that's the angle that it's ramping down into the cut. 2 degrees should be perfectly fine. If we were running our feed rate at a much higher rate of speed, we could adjust our entry feeds and speeds in order to ramp a little slower down into the cut. For this tutorial, I'm going to go ahead and leave that unchecked since we're only running at 25 inches per minute, but you can adjust it here. You could slow it down if you needed to. For our steep and shallow, I'm going to go ahead and adjust for stock to leave. I'm going to set our minimum depth to 0, so that's the very top surface of our part. And our maximum depth, this is where we're going to tell Mastercam how far below the bottom of the part we want it to go. So I'm going to set that to negative 0.76. So this will allow it to go 0.01 below the bottom surface of our part. In our linking parameters, our clearance plane, I'm going to set to 0.2. Again, I want that set from absolute. This way it'll be based off of the top surface. We can leave our retract to full vertical retract. You can see in here you've got a couple different options where it's going to be like minimum, so it'll only go as much as it absolutely has to clear different surfaces, or you have minimum distance, so it's going to just kind of angle up and around any obstacles. But we'll go ahead and leave it to full vertical retract for this tutorial just to be on the safe side. So it's going to come all the way up and across and then drop down into the cut. For our linear entry and exit, so this is the little line before we arc into our horizontal arc entry, I'm going to set that to 0. I'm just going to come straight down into that horizontal arc and then into the cut. So I don't want anything vertical or linear. For our horizontal arc entry, I'll go ahead and set that to 0.2. So it's going to have a 0.2 lead-in radius into the cut. I'm going to do the same thing for our exit, 0.2. I don't need a ramp angle or vertical arc entry or exit. Again, I just want to come straight down and then arc horizontally into the cut. I'll leave our fitting to default. That should be fine. Again, I don't need to mess with our tolerance. In our planes tab, we just want to double check that everything is set to G54. And in our coolant tab, we want to set our flood to on. Now again, I don't need to mess with anything beyond our coolant, so I'm going to go ahead and click OK. Okay, so you can actually see where it's dropping down right here. It's going to be starting in our pocket. So it's going to spiral down till it gets to the bottom of our pocket, and then it's going to start cutting out the bulk of the material in this pocket. Then it's going to come and lift up, and then it's going to drop down on the outer profile and start cutting out the outer profile. And then it's going to move to this step and start cutting that out. So that looks great. Let's go ahead and backplot it so you can see. All right, spiraling around that pocket. Perfect. So now that the top face is finished and the outer profile and pockets are roughed out, now we can begin doing some finishing toolpaths. So the first thing we want to finish is the outer profile of the part, and then we'll work our way in. In order to finish the outer profile, we're going to come up to our 2D menu and choose Contour. So again, this is a 2D toolpath, so it's only relying on that 2D geometry that we're going to select. So I'm going to leave our selection method to edges, and I want to select the very outer profile of our part. So I need to be very careful here that I don't accidentally select the bottom edge of our chamfer. I want to make sure it's the outer profile. So it's going to be this one up here. I'm going to hold Shift on my keyboard and I'm going to click. I want to make sure that the arrow is pointing to the left of the contour. This way the tool will be on the outside of this profile, and that way we can climb mill in the left direction around the part. So if for whatever reason your arrow is pointing the wrong direction, you could just choose this reverse button here and you can see it'll swap it. I'm going to leave it pointing to the left though. And now we can go ahead and click OK. So now you can see we've got our chain geometry selected here. In our tool tab, we're going to be using that same 3/8 flat end mill. I'm going to set our feed rate for this to 20 inches per minute. Whenever we're doing a finishing toolpath, we like to slow it down a little bit to really get that nice finish. For our plunge rate, since we're going to be plunging off of the material, I'll go ahead and set that to 100 inches per minute again. And our spindle speed, 4,000 RPM. And I do want to check rapid retract. Again, we don't need to mess with our holder tab. In our cut parameters, it's very important. I want to make sure, since this is a finishing toolpath, that I set my compensation type to wear. This will allow me to control the tool diameter right at the machine controller so that I can dial in the overall width and length of my part right at the machine rather than having to come back and tweak the program and repost it. I can just add a little bit of compensation to my tool, either negative or positive, depending on whether I need the part to be a little larger or a little smaller to be to the print. Wear allows us to do that. For our compensation direction, just like we talked about before, since we want to be climb milling, we want it set to left. This way the tool is going to be traveling around the part in the left direction, which is also climb milling in this case. For our tip comp, I'll go ahead and leave that to tip. For a roll cutter around corners, we'll go ahead and leave that set to sharp. Since we've already got a radius modeled in on our part, I don't need to mess with our external corner break radius. If this was a sharp edge and we wanted to add just a little radius here, we could go ahead and do that by adding an external corner break radius. But since it's modeled in, I'll just leave that at 0. Since this is a finishing toolpath, again, I'm going to go ahead and leave my stock to leave on walls and on floors set to 0. And our contour type, we're going to leave that to 2D. So this is just a regular 2D contour finishing the outer profile of our part. We don't need to mess with depth cuts. We're just going to come straight down to the bottom and cut around the outer profile. In our lead in and lead out, I want to uncheck enter and exit at midpoint and closed contours. Now, the reason for this is because if I left it checked, it would actually start the tool right here in the center of that first contour we selected. And I don't want it to do that because I know that when the tool comes down and it enters into the cut and it comes back around and exits in that same spot, it's probably going to leave a little tool mark on my part. And so I'm going to actually have it start on the corner, on the edge of our part. This way that corner hides that little tool mark as it enters and exits the cut. So by unchecking this, it'll start on the corner of where that first contour was that we selected. So I'll uncheck that. And for our line type, I want to set that to perpendicular. A lot of machines require a perpendicular entry in order to utilize the cutter comp that we set earlier. So for this tutorial, I'm going to set it to perpendicular. For our length, I'm going to set that to 0.2. So our perpendicular line will be a 0.2 line, and then we're going to have a radius of 0.2 as well. So I'll set my radius to 0.2. So we've got that 0.2 perpendicular line and then a 0.2 radius into the cut. I'll leave our sweep angle at 90 degrees. And then I'm going to copy all of this over to our exit. A quick way to do that instead of typing it all out is just to click this button here. And now you can see it's all exactly the same as our entry. I don't need to mess with breakthrough, multi-passes, or tabs. In our linking parameters, once again, I want to make sure everything is set to absolute. This way we know anything positive is above the top surface of the part and anything negative is below and probably engaged. Our retract, I'm going to set that to 0.2. Our feed plane, 0.1. Our top of stock is 0. And our depth, we want to go a little bit below the part, so I'm going to go negative 0.76. I don't need to mess with our hone tab. We'll leave that to default. Our tolerance, I'm going to go ahead and leave all that as well. In our planes tab, I just want to double check everything set to G54. And in our coolant tab, I want to set flood to on. And then we'll click OK. All right, so you can see we've got that perpendicular line, 0.2, and then a 0.2 radius into the cut. And it's going to climb mill around the outer profile. Let me go ahead and backplot that so you can see. Perfect. Starting on that corner to hide any witness marks from the tool entering and exiting the cut. And you can see it's just a little below the bottom surface of our part. And then exit. Perfect. Okay, so since we're on the outside and we're working our way in toward the center, let's go ahead and finish this step next. So we're going to be using a 2D contour again. So I'm going to click OK. I'm going to come up to our 2D menu and choose contour. Now we want to select the geometry around this step here. But since we've got this chamfer modeled in, it's a little funky. It would be a lot easier just to select this bottom edge of our chamfer up here in order to get the entire geometry of this step. So I'm going to start by clicking this edge here. Depending on what side of this edge I click, it's going to determine the direction that it's traveling. So if I click the left side of the line, the arrow is going to be pointing to the right. If I click the right side of the line, the arrow will be pointing to the left. So if I always click the right side of the line, it'll be a little bit easier. I won't have to reverse it or worry about the direction. So I'm going to click the right side of the line. And now you can see the arrows pointing to the left, which is the direction I want. But I want it to go all the way across, just the step, not all the way around the part. So now that I've got that selected, I'm going to choose next, and it's going to move the contour along. I'll hit next again, and one more time, and now I've got that entire contour selected. So now I'll click OK. I'm going to go to our tool tab. We're going to be choosing that same 3/8 end mill. You can see if I don't click anything, it's automatically got the same parameters from our last contour. Mastercam will kind of take any of the parameters that you change in the last toolpath, if it's the same type of toolpath, in this case contour, and keep all of those parameters the same. So we've already got everything in here the way I want it. I want my feed rate 20 inches per minute. I want my plunge rate 100 inches per minute. Our spindle speed 4,000 RPM, and I do want rapid retract checked. And we've got the correct tool, so that all looks good. Again, don't need to mess with the holder tab. In our cut parameters, it's also remembered from our last toolpath that our compensation type we want set to where. We want our direction set to left. Everything in here is going to be the same, so I'll go ahead and leave all of this. I'm not going to mess with depth cuts. In our lead in and lead out, for our enter and exit at midpoint and close contours, that really doesn't matter in this toolpath. I'm going to leave it unchecked, but since this is not a closed contour, it's actually going to start out the end anyway. But I'll leave that alone because it doesn't really matter. I'll leave our entry set to perpendicular, 0.2 length, 0.2 radius, 90-degree sweep. So all of this is going to be the same, so I'll leave that alone. Again, I don't need to mess with breakthrough. In multi-passes, we do want to do this in multi-passes because the distance from this edge to the center of our step here is greater than the diameter of our tool. So if we just did it in one pass, it would actually leave a little island there. So we want to do it in 2 passes. So I'll go ahead and check multi-passes. I'm going to leave our roughing set to 0 because we're just going to do a finishing pass. I'm going to set the number to 2, and the spacing I'm going to set to 0.2. I also want to check keep tool down. This way it doesn't retract between passes. It'll just loop back around and do the next pass. Everything else in here I'll leave to default. I don't need to mess with our tabs. In linking parameters, I just want to double check that everything is still set to absolute. Our retract is 0.2, feed plane 0.1. Top of stock is 0, and our depth for this, I want it to be at the depth of our step here. So looking at our print, I can see that that is going to be 0.5 below the top surface. We can also select this button here, and I can choose a point at that height, and it'll automatically set it to -0.5 as well, which makes it pretty easy if you don't have the print or don't know what that distance is. Again, we don't need to mess with our home tab or our tolerance. In our planes tab, everything is still set to G54. And in our coolant tab, it remembered from our last contour that we want flood set to on. So that looks great. And now I'll go ahead and click OK. All right, so you can see where the tool drops down. It's going to come around, take its first pass. Then it's going to stay down at that level and move on to the second pass. So let me go ahead and backplot that so you can watch the tool. So I'm going to drop down. Got that perpendicular lead in and that horizontal radius, and then it's going to come and take that first pass. And then it's going to stay down, swing over into the next pass, finishing that step. Perfect. and then lift. Okay, so we're working our way in toward the center of the part. So the next thing to do is to finish this pocket. So I'm going to click OK. I'm going to come up to our 2D menu, drop down, and I'm going to choose Pocket. So we want to select the entire profile of our pocket. So I'm just going to hover over an edge inside of our pocket. Again, I want to make sure that I'm kind of to the right side of the edge so that the arrow is pointing left. And I'm going to hold Shift on my keyboard and click. That's going to automatically select the entire profile of our pocket. And we've got our arrow pointing the correct direction, so now I'll click OK. In our Tool tab, we want to set it to that 3/8 flat end mill. I want to set our feed rate to 20 inches per minute, our plunge rate to 100 inches per minute, and our spindle speed to 4,000 RPM. We are going to be plunging into this pocket, but we've already cut out the majority, and we're only going to have 5 thou of material left here, and we're actually going to ramp down into that material, even though it's just a small amount. For our retract, I want to set it to rapid retract. Don't need to mess with the holder. In our cut parameters, I do want our machining direction set to climb. I'll go ahead and leave our tip comp and roll cutter to default. Our pocket type is going to be standard. And I want to go ahead and zero the stock to leave on our floors and walls. Again, this is a finishing toolpath, so we want to clean everything up. In our roughing tab, this is where we can choose what type of toolpath we have. So you can see there's a lot of different options here. And I'm going to go ahead and choose parallel spiral. Everything else in here, I'll go ahead and leave to default. For our entry motion, I do want it set to helix. For our minimum radius, I'm going to set that to 40% of tool. So that's 0.15. For our maximum radius, I'm going to do 50% of tool. For our Z clearance, I'm going to set that to 0.05. So it's going to be starting 0.05 above the material. For our X and Y clearance, 0.1 is fine. And for our angle, we're going to set that at 2 degrees. For the direction of our helix, I want to set that to counterclockwise. Since this is an internal cut, the counterclockwise direction is actually climb milling. Everything else I'll go ahead and leave to default. In our finishing tab, I do want 1 pass, and the spacing on that is going to be 0.005. So this is when it goes to clean up that last little bit on the walls, it's going to have a pass that's 0.005 away from that. So saving the walls for last. I also want to check keep tool down. This way it doesn't retract before that final pass. And I want to set my cutter compensation to wear. This is a finishing pass, and we want to make sure that we can control the cutter comp right at the machine to control the size of the pocket. So we'll make sure that that is set to wear so that we can do that. In our lead in and lead out, so this is really just for that finish last pass around the walls. So I'll go ahead and set my length to 0.2, my radius to 0.2 as well. And I'm going to set our sweep angle to 45 degrees. This way our arc is at a more shallow angle to the cut. And I'll go ahead and copy all of this over to our exit. So I'm just going to click this guy here. And now it all is exactly the same. I don't need to mess with depth cuts or breakthrough. In our linking parameters, I want to set everything to absolute. Our retract we'll set to 0.2. For our feed plane, I'm actually going to set this to a negative number. So we know that we want to plunge down into this pocket and then spiral down into the cut. And since we have our entry motion set to a ramp, if I set our feed plane and our top to a negative number, it's going to start that ramp down closer to the material. So since I know that this pocket is negative 0.5 deep, I'm going to set my feed plane to negative 0.4. So it's going to be 100 thou above the material that it starts the feed rate. I'm going to do the same thing for our top. I'm going to do negative 0.4. This way it starts that ramp about 100 thou above the bottom of this pocket. For our depth, I know that it's negative 0.5, so I'm going to type negative 0.5. And that all looks great. So in our home tab, again, I don't need to mess with anything in there. Tolerance. In our planes, everything is still set to G54, so that looks good. And in our coolant tab, I'm going to set flood to on. And now I'll click OK. All right, so we can see here where our tool is going to start. It's actually going to drop down. Then it's going to start the feed rate, and it's going to spiral down into the pocket, working its way out to the outer profile. And then it's going to take that final finishing pass. So let's go ahead and backplot it. Just dropping straight down, spiraling into the cut, finishing up the floor of the pocket. One final pass around the wall before it takes its finishing cut. And you can see we've got that 45-degree angle into our cut and our exit. Perfect. All right, so now we've finished the top face, we've finished the outer profile, our step, and our pocket. So the next thing we want to do is start on our chamfering. So let's go ahead and start with the top chamfers of our part. So I'm going to go ahead and click OK. I'm going to come up to our 2D tab here. I'm going to choose the drop down, and I want to choose Model Chamfer. Now I'm going to choose our chain geometry. So I'm going to hit the selection arrow. So for our outer chamfer, I want to make sure that it starts on this same corner for the same reason. I want it to hide any tool marks as it's coming into the cut. Obviously with a small 10-thou chamfer like this, it's not going to be as noticeable, but anytime you can start a tool on a corner to hide any tool marks, it's best to do so. So for our selection method, I'm going to go ahead and set it to loop. And I want to mouse over the top contour of our chamfer. And once again, I want to make sure that I'm mousing over the right side of this edge here. This way our arrow will be pointing to the left, which means the tool will be on the outside. So I'll go ahead and click. And we've got our arrow pointing the correct direction. Now for internal chamfer, I don't want the tool to start in any of these internal radiuses, just because they're a tighter space. So since I've got this angled wall here, I'm going to go ahead and use it to our advantage. I want the tool to start right on this edge here. So I'm going to mouse over that contour, again the very top edge, and I'll click, and so you can see that's where the tool is going to start. So now that I have both the internal and external chamfers selected, I'm going to go ahead and hit OK. And in our tool tab, I'm going to choose tool 3, our 1/4 inch chamfer mill. I'm going to do a feed rate of 20 inches per minute. We are going to be plunging outside of the material, so I'll set my plunge rate to 100 inches per minute. I'll leave my spindle speed at 4,000 RPM. And I do want rapid retract checked. In our cut parameters, this is a finishing toolpath, and we want to be able to control the chamfer width right at the machine controller using the diameter wear of the tool. So I'm going to set my compensation type to wear. Our compensation direction, we do want set to left. This way it'll be climb milling. I'm going to leave tip comp, roll cutter, round corners, all of that to default. Stock to leave at 0. I don't need to worry about corner radiuses. For our chamfer width, since on this model, the chamfers are modeled in, meaning I can see them on the model, I don't need to set a chamfer width. If these were sharp edges, then we would go ahead and add our chamfer width here, but I don't need to mess with that for this part. For our bottom offset, I always want to make sure that my bottom offset is greater than the width of my chamfer where at all possible. This way the tip of the chamfer is actually hanging off the edge a little bit, which will give us a nice clean chamfer if the tip was right at the bottom edge of our chamfer, then it could potentially leave a lip at the bottom of the chamfer, and we don't want that. So my bottom offset, I'm going to set to 0.05. Since this is a 10 thou chamfer, that should be plenty. I don't need to mess with depth cuts. In our lead in and lead out, I do want to make sure that enter and exit at midpoint and closed contours is unchecked. This way it'll start on the corners of the part where we selected our contour. I'm going to go ahead and set our length to 0.1 and our radius to 0.1 as well. And then we'll set our sweep angle to 45 degrees. This way it'll be coming in at a more shallow angle to the cut. I also want to copy this all over to our exit. The way to do that is to click this guy here. And now you can see it's all plugged in there. It looks exactly the same. I don't need to mess with multiple passes. In our linking parameters, I'm going to set our retract to 0.2 and our feed plane to 0.1. We don't need to mess with the home tab or tolerance tab. I'll double check my planes are G54. And in our coolant tab, I want to set flood to on. And then I'll click OK. All right, so it's going to start on the inside here. You can see where it's going to drop down. We've got that 45-degree angle with that 0.1 radius right there. And you can see it's offset off of the edge. Let's go ahead and back plot it so we can watch. Go ahead and stop it. All right, so you can see how far it's offset off of the edge of the chamfer there. So that looks good. Then we're going to lift and start on this corner here. And we can see we've got that same offset there. And it's just perfectly taken off that edge there on that chamfer. Perfect. So now that we've finished the top chamfers of our part, let's go ahead and tackle the chamfer on this step here. So I'm actually going to use that same toolpath because a lot of the parameters are going to be the same. So I want to go ahead and copy and paste this toolpath so that we can use a lot of the same parameters. So I'm going to right click, copy, then I'm going to right click, paste. Now I'll left click the parameters here, and I'm going to come up to our toolpath type, and you can see our current chain geometry here. So I'm going to remove our current chain and reselect the new chain. So I want to select the top edge of our bottom chamfer here. So I'm going to set our selection method just to regular edges. Now I just want to select again on the right side of the line so that the arrow will be pointing to the left. And it is pointing to the left, so that looks good. And then I'll click OK. Now, since we don't want the tool to crash into this wall here, under our avoidance model here, I'm going to set our clearance to 0.03. This way it'll have about 30 thou of clearance between this wall and our tool. That will allow the tool to get as close as possible to this wall without hitting it so that we can get a clean chamfer as far across as we can. In the tool tab, I'm going to leave everything in here the same. In our cut parameters, let's go ahead and offset the tool a little bit more off of the bottom of the chamfer. This way we can get a clean chamfer as close as we can to this wall. So we'll do 0.09. Everything else in here will leave the same. Everything else should be exactly the same. Yep, looks good. I'll click OK. Now, since we copied and pasted this toolpath, we need to regenerate it since we edited the parameters. So to do that, with it highlighted, I'm going to come up to regenerate all selected operations. And now we can see where the tool is going to drop down. It's going to arc into the cut. Let's go ahead and backplot that. Now I'm just going to step it through because I want to see how close we get to the wall. We do have clearance there. Perfect. And you can see we could go a little bit further up the tool even to get the chamfer a little bit further across, but this gives us a little bit of tolerance here on our tool. Perfect. Okay, so now that we've got our top chamfers and our step chamfer done, let's go ahead and chamfer all of the holes. Since we've got the tool out, this also doubles as a spot drill. If you're using the Kennametal Building Blocks Toolkit, which contains the Go drills, those drills are self-centering, so you don't actually need to do a spot drill toolpath. But in case you're using a standard drill, I'm going to show you exactly how to do that. So I'm going to click OK. I'm going to come up to our 2D drop down here, and you can see under the hole making tab, I'm going to choose chamfer drill. So I'm going to select each of our holes, and I'm going to select them in the order that I want them to be cut. So I'm going to try to be as efficient as possible in how I'm selecting them. So I'm going to go from left to right. I have my sort order set to selected order for that reason. You can see there's a lot of different options in here to optimize the order that it cuts, but I like selected order since I can just choose them in the order I want them to cut. So now I'll click OK. And in our tool tab, I'm going to choose that 1/4 inch chamfer. I'm going to set our feed rate to 20 inches per minute. I'm going to go ahead and set our plunge rate to 20 as well. I'll leave our spindle speed at 4,000 RPM, and I do want rapid retract checked. I don't need to mess with holder, stock. In our cut parameters, since the chamfer is modeled in, I don't actually need to set anything in here. If these were just sharp edges on the model and I knew what my chamfer width or depth needed to be, I could set that here. But since it's modeled in, I'm going to leave those set to 0. I don't need to mess with tool axis control or limits. In our linking parameters, I'm going to set everything to absolute. For our clearance, I'm going to set that to 0.2. And I'll leave everything else to default. I don't need to mess with home, safety. Our planes I want to double check are G54, and our coolant I want to make sure flood is set to on, and then I'll click OK. All right, so we can't exactly tell what's going on here, so I'm just going to backplot it, and I'm going to step it through so we can see we're starting on this hole here. And you can see it finds that perfect depth to get that chamfer that's modeled in on our part. And it's just going to retract and move to the next one. Boom, take the cut, move to the next. Perfect. Okay, so now that all of the holes have been spot drilled or chamfered, I'm going to go ahead and click OK. So now we want to drill the holes. So I'm going to come up to our 2D menu drop down, and I'm going to choose drill. And we're going to do the same thing. I'm just going to select each hole in order. I'm going to choose the exact same order as last time. And my sort method set to selected order, and I'll click OK. Under our tool tab, I'm going to be using that 0.1772 drill. I'm going to do a feed rate of 18 inches per minute and our spindle speed 4,000 RPM. I don't need to mess with holder, stock. In our cut parameters, I'm going to go ahead and set our cycle type to a chip break. So the difference with a chip break is, since we've got our PEC set to 0.1, every 0.1 that it pecks down, it's only going to retract 0.1, whereas like a PEC drilling cycle is going to come all the way up out of the hole before it takes the next cut. So this is much more efficient since every peck it takes, it's only going to retract a little bit just to throw that chip out of the hole and then keep cutting. So I'll go ahead and leave my peck to 0.1 for this. I don't need to mess with those tabs. In our linking parameters, I want to set everything to absolute. I'm going to set our retract to 0.2. Our top of stock is 0. And for our depth, since our print calls out a thread depth of 0.380 minimum, we want to make sure that our tap goes past that a little bit so that we get a nice clean thread all the way down to that 380. Since most taps have a little bit of a taper on the tip of the tap, we want to make sure that we go down a little bit below the minimum depth of our threads. Since we're going to be going deeper than our thread depth, I want to make sure that our drill goes even deeper than our tap does. This way there's some clearance between the depth that our tap is going and the depth that our drill is going. So I'm going to set our depth to negative 0.580. And I don't need to mess with any of these tabs. Our planes are G54 and our coolant, we want to set flood to on. And then I'll click OK. All right, so let's go ahead and backplot it. And I'll go ahead and hit play. So you can see it's not retracting out of the hole completely each peck, making it much more efficient than a peck drill. That looks great. All right, so the last toolpath is our tap. So since we've already got the geometry selected with this toolpath, I'm actually going to use this toolpath to create our tap toolpath. So I'm going to right click, copy, and right click, paste. And I'll go ahead and left click our parameters. So our geometry is already selected, so I'll leave that alone. In our tool tab, we do want to switch to our tap. And now I want to set our spindle speed to, I'm going to do 600 RPM. This can be adjusted based on your machine. You want to make sure that you're going a little bit faster than whatever your minimum speed is. You know, if your machine can only go 500 RPM, make sure it's 550 or 600. You could always increase the spindle speed based on the capability of your machine. But for this tutorial, we're going to do 600. Now you see if I click anywhere on the screen, it's going to automatically adjust my feed rate to match the spindle speed for this tap. So I'm not going to mess with the feed rate because it's pre-calculated for me. Now we can come to our cut parameters. And here I want to change our cycle type to tap, since that's what we're going to be doing. And in our linking parameters, remember that we want our tap to go not quite as deep as our drill did. So I want about 100 thou difference between the two. So I'm going to go negative 480. And that should give us plenty of thread all the way down to that minimum depth of 380 for our threads. So that all looks good. Everything else should be the same. And then we'll click OK. Now again, I need to regenerate this since it's copied and pasted. And you can't really see a difference in the toolpath, but we'll go ahead and simulate it so you can actually see the difference. So I'm going to hit play, and you can see it's just going to come straight down, tap, move on to the next. All right, that looks great. So now all of our toolpaths are finished and programmed. One thing I do want to check before we're finished is I want to verify all of our toolpaths simultaneously. This way I can see what the final product's going to look like when all the toolpaths are done. So in order to do that, we actually need to set up our stock in our properties tab here. So we can come to our stock setup, and just like before, I'm going to choose that same stock model we created since I can quickly select it. So I'm going to choose solid or mesh. I'm going to choose the selection arrow, and I'm going to come over to our levels tab here, turn on our stock model, and I'll just choose that guy right there. If I wanted to be extremely accurate, I could create a separate stock model that has the 20 thou of material on the top for my face mill. But since I know the face mill is just going to be skimming the top to the top surface of our part, I'm not too worried about it. I could also choose a rectangular shape and just create my stock here for simulation. But for this tutorial, I'm going to go ahead and just use that stock model we already created. And then I'll click OK. Now I'm going to turn our stock level back off and come back to our toolpaths tab. Now I want to select our last toolpath, and then I'm going to hold Shift on my keyboard and select our first toolpath. That'll select all of them at the same time, and you can see they're all previewed on the screen here. Now I can come up to Verify Selected Operations. That's going to open a separate window. And when I'm verifying my toolpaths, I like to make sure that I have my tool visible and my stock visible. You could turn on your workpiece, which is the actual model of the part, but in this case, I like to see what the final product looks like. And to make it less confusing, I'm just going to turn off my workpiece so that I only see what the final result looks like cut out of the stock. So since we've already previewed all of our toolpaths by backplotting them, I don't really need to watch each individual toolpath, so I'm going to set my speed to as fast as possible, and then I'll go ahead and just hit play. So it's roughing out the bulk of the material. Now we're tapping, and it looks like it's all finished. So I can see all of my chamfers. I can see some clearance between our tap and our drill. I don't see any gouges. That all looks great. So now that I've verified all of my toolpaths simultaneously, I can go ahead and just close this window here. And now we're back to the main Mastercam screen. Now in order to post our code with all of our toolpaths selected, I can come up and choose Post Selected Operations. Now, depending on your post file and your machine, some of these parameters may be different, but in this tutorial, I'm going to leave everything to default and click OK. Now it's going to ask me to save my NC file. I want to make note of the directory it's saved in so that I can copy it over to my machine. And once I've given it a name or left my name to default, I can go ahead and click Save. Now it's going to generate the code, and it'll automatically open it in Code Expert. Here I can make any necessary changes I need to the code and save it, and then when I'm done, I'll close it and load it into the machine. So the programming for this part is now complete. I hope you enjoyed this video. Thank you for watching.